So this section is big idea number 5 on programming. This screencast is to help prepare students for the programming questions on the AP Computer Science Principles test. So let's get started. Alright, so this section is quite a big one. There's 26 questions. So let's start off on number 1. So this type of question requires us to visualize what's going to happen. So it says the robot below has an additional method, rotate left, in which the robot rotates in place 90 degrees counterclockwise. So it's going to make an in-place left turn. So here it shows us the maneuver. It says which of the following code segments will allow the robot to move in an L shape assuming the path is clear. So at the moment it's right here. And then the first thing that we are told is move forward. So that gets us here, one spot, and then move forward again. So that gets us this spot right here. Rotate left. So now it's going to turn up. Then rotate left again. So now it's going to turn to the left. Rotate, so it's this one. Rotate left again. So now it's going to face down. And then move forward is going to get us here. So therefore the first answer is A. And if you go through the others, they don't quite make it there. So question 1 is A. Okay, here's number 2. Okay, so in this question we're told to consider if can move forward, then move forward. And then after that if statement, we need to rotate right. So that's pretty much doing a 180 turn. And then if not can move right, then move forward, then rotate right. So it says for the following initial situation, what will be the final position and direction of the robot after the code is executed? So we see where it is right now. And we're told if can move forward, then move forward. So it can and it does. Now we're told rotate right, so it's going to be in this position, but it's now going to be facing down. Rotate right again, so it's in this position, but now it's facing this way. And then if cannot move right, do this stuff. But it can move right, so keep in mind it's currently facing this way. It can move right, so it doesn't execute this stuff inside. So it just ends up like this. So that answer is B. All right, the next question, number 3. All right, so number 3 is also a question where we have to consider this segment. If can move forward, then move forward. So let's do it. This is what we're given here, and it wants to know where it is at the end. So if can move forward, move forward. So it's going to move forward. Okay, if cannot move forward, which it currently cannot move forward, then it should rotate right. So now it's facing up. And then rotate right again. So now it's facing back on itself. And then that's it. So D would be our answer for question number 3. All right, so next is number 4. Here goes. So in this one, we start with this situation, and if we jump below the code segment, we're told the code does not run as intended for the robot in the following scenario. Why not? So here it is, and we're told repeat until cannot move right. So not can move right. So at the moment, can it move right? Well, no, because it's blocked out here. So it cannot move right. So therefore, all of this stuff is not going to work because it's stopped at the start line. So therefore the initial condition is not met, so the code in the repeat until loop is not executed. So that's our answer A. Okay, number 5. So number 5, here's where we're starting. There's code segment, and we're told for the following initial situation, what will be the final position and the final direction of the robot after the code is executed. So repeat until cannot move right. So at the moment, can move right, so it's going to do the stuff inside. So if can move forward, so it comes right here. And then if cannot move forward, which it can't because it's going to fall off the page, so it can't move forward, so now it's going to execute this. So rotate right, so then it's facing up. Rotate right again, so now it's facing to the left. It's facing to the left, it's pointing towards itself. And then move forward, so now it's going to be in this cell right here. And this repeat jumps all the way back up to the top. Repeat until cannot move right. Well, it can move right, so then it does the same. It turns around and it's going to keep bouncing back and forth, back and forth. So the answer is going to be D. There is an infinite loop, so it keeps going and going and going. So number 5 is D. Let's take a look at number 6. All right, so number 6 says consider the following code segment. Repeat until can move forward. Rotate right. So which of the following are possible outcomes of the above code? And it says select 2 answers. So let's say we've got a little robot. It's here. All right, so it's facing this way. And there's a couple of situations. One is where it's completely trapped in a box. Another situation is where maybe there's some kind of like way out for it. So at the moment it's facing to the right, but there is a way out. It's not completely trapped. So in the first case, repeat until can move forward. Well, currently it can't move forward. So then it turns right, so it faces down. Now it still can't move forward, so it rotates right. So it's facing to the left. Can't move forward, so it turns around, now it's facing up. And that's going to keep happening. It's going to go on forever and ever and ever. So the robot will get stuck in an infinite loop is one of the possible outcomes if the robot is completely blocked. So it says select 2 answers. So the next answer is with a situation like this. So if it's facing to the right, repeat until can move forward. Well, currently can't move forward. So the instructions say rotate right. So after it's rotated right, it's now pointing down, still in the same grouping. So because it can now move forward, it stops, the repeat stops. It doesn't say that it wants you to move forward. It just says repeat what's inside until you can move forward. Well, you can move forward right now, so you don't need to do anything. You don't rotate, the whole script stops. So that's this one. So the robot will move forward. Well, no, it's never going to move forward. So that's not true, because the command doesn't tell it to move forward anywhere. It just tells it to see if it could possibly move forward, but it doesn't say move forward. B says the robot will return to its original position. Well, only if it moves off the square and then moves back is it returning to its original position within the grid. Just rotating isn't returning to its original position. So C, the robot will be in a position in which it can move forward. Well, currently in this very final grid, it is in a position to move forward. So therefore the answers for 6 are C and D. Okay, question number 7. So here we've got this grid and we're told consider this situation. And it says what will be the final location and direction of the robot after the following segment of code is run. So it's pretty small, but it's up there. It's facing to the right. It says repeat until cannot move forward. Well, currently it can move forward. It's possible for it to move forward. And in fact, it does, because it says if can move right, which currently it can't move right because of all these black boxes, so it can't move right. So then what it does is it rotates right and moves forward. So if can move right, which it can't, so let me back up a second. So repeat until can move forward, not can move forward. So it can move forward, so it's going to go into this stuff right here. So if can move right, do these things. it currently can't move right, so it doesn't do these. What it does instead is it moves forward. So therefore on this cell right here, it's currently facing the wall now. So as we go back up to the top, it says repeat until cannot move forward. Well, it can't move forward in this square, so therefore the repeat stops. And so it's a little messy up on the top where I've drawn it, but I'm trying to draw what C looks like. So it's repeated this whole thing until cannot move forward, and it cannot move forward when it gets here. Okay, number 8. Okay, so consider the following incorrect code segment meant to guide a robot through the maze below. So repeat until not all of these things, until it cannot move right, cannot move left, cannot move forward, cannot move back. It wants to repeat this script here until it cannot do these things. So let's take a look at the moment. Cannot move forward, cannot move right, cannot move backwards, but it could move up, or it could move to the left even. So therefore it's going to repeat because not all of these nots are satisfied. So if can move forward, else rotate right. So it can't move forward, so it rotates right, which means it points down. Now in this spot here, it can't move forward again, so it rotates right. Now it can't move forward again when it's facing this wall, so it rotates right, and now it's pointing up. Now if it's pointing up, if can move forward, so it does, it comes here. And then it keeps going, because while it can move forward, it's going to keep moving forward. Now at the top, it can't move forward, so if can move forward doesn't work, else rotate right. So what it does is it turns to the right, and then it keeps moving. So it's going to keep moving in this direction because the if statement is always true that it can move forward, and when it gets to the end, can move forward is false, so it doesn't do this. But what it does is it rotates to the right, so now it's pointing down, then it keeps moving forward, and when it can't move forward anymore, rotates to the right, rotates, and when it can't move forward, it rotates to the right. And then when it can't, and what it's doing now is it's facing the black, and when it can't move forward, it rotates to the right, and then it comes back over here. So it never makes it all the way around this maze. And so the bit where it gets stuck is right here in D, because this is the problem area, that it can't move forward and it doesn't turn left, it turns right. So D is the answer, and this thing starts to kind of get stuck in between these two squares right here. So the answer for 8 was D. So question number 9, this comes from the formula supplemental sheet that you get during the computer science test. And so it's a slightly different representation. So we're told at first that x is given the value of 0. So when x equals 0 and it goes in, so this is our first run. When 0 is here, 0 is not greater than 5, so it does repeat everything. So when 0 goes in here, 0 mod 2, so 0 divided by 2 is 0, so 0, and there's a remainder of 0, so 0 does equal 0, so it does this next step here, so x takes on 0 minus 1, so therefore x takes on 0 minus 1, so x takes on negative 1. Next, so we're still in the first repeat, so not negative 1 mod 2 equals 0. Well, negative 1 mod 2 leaves a remainder, and so the remainder is not equal to 0, so this is therefore true because of the not. And so what we do is the x comes here, which is negative 1 plus 3 is going to be 2. So x takes on the value of 2. So with the first loop, that's the first time we end up with x equals 2. Now the second time, let's take a look. So we know that going into this x equals 2, 2 is not greater than 5, so we do continue with this repeat. 2 mod 2 leaves a remainder of 0 because 2 divided by 2 is 1, remainder 0. So therefore we consider this stuff here. So the x is still 2, but then it's given the value of 2 minus 1, which is 1. And then 1 mod 2 is 1 divided by 2, which leaves us with 1/2, which does have a remainder that's not 0. And so it's true that that non-zero is not 0. So therefore, the x, which was 1, gets the value of 1 plus 3, which is 4. So x now equals 4. That jumps to the top. So now we're questioning, is 4 greater than 5? Well, it's not. So in our third loop, x gets the value of 4. 4 mod 2 is 4 divided by 2 is 2, remainder 0. So 0 does equal 0, so it runs this bit. So x is given the value of 4 minus 1. So that means that x gets the value of 3. Now, in the next section, 3 mod 2, well, 3 divided by 2 is 1 whole remainder 1. So it's correct that 1 does not equal 0. So if 1 does not equal 0, it means we've got to run this next bit of code. And if x is 3, which we have so far all the way over here, x then becomes 3 plus 3, which is 6. X equals 6. So now we've got to think, repeat until, well, 6 is greater than 5. Well, that's true. So therefore, we stop. And so the question was, how many times will the following loop be executed? Well, the first time this stuff happened, the second time this stuff happened, and the third time this stuff happened, and then it stopped because the x value was greater than 5. So this thing ran 3 times. That was question number 9. Okay, 10. Assuming that a and b are integers, so a and b are integers, and b is less than 0, what can we assume is true after the following code is executed? And select 2 answers. So we're told over here that a is given the value of 0. So a is given 0, and we know that b is less than 0. So we know that b is some negative number. So at the very start it says repeat until this is true. Well, a is given a value of 0, and 0 is not less than or equal to a negative number, so this script runs. So a is given, and at first a is 0, but then it's given the value of 0 minus 1. So that means that a takes on a new value of negative 1. And then negative 1 goes in, and depending on what b is, this either keeps running or it stops. Now, we know a few things. We know that a must be negative, because it's going to keep, it originally was 0, and then we'll keep subtracting 1 from it. So we know that a must be negative. And then if we keep thinking about this, at what point will it stop? Let's just make an example that b is negative 3, because it's possible. We know it's less than 0. So if b was negative 3, we're dealing with a situation where this will stop when a is less than or equal to negative 3. Well, let's say that a was negative 2. So is negative 2 less than or equal to negative 3? Nope. So it runs and it does this stuff. And then a then becomes negative 3. And is negative 3 less than or equal to negative 3? Well, it's equal. And so this whole repeat will stop when they are both equal. So a must equal b is the other answer. So a and d are the correct answers for 10. All right, next. So here's number 11. So it says, which of the following code segments from procedures will display computer science principles, CS principles 5 times? And it wants us to select 2 answers. All right, so let's take a look. Counter is set to 0 in A, and then repeat until counter is more than 5. So, okay, so counter first is 0. So it displays computer science principles, so I'm going to put a check. It does it once, and then it increases the counter by 1. So now the counter equals 1. Okay, and we have 1 check. Now it's going to display it again, and then the counter equals 2 because it's going to add 1 to that counter. And then it's going to display it again, and the counter is going to equal 3, and it's going to display it again, and the counter is going to equal 4, and then it's going to display it again, and the counter is going to equal 5. And now if the counter is 5, that means that this is 5. Now 5 is greater than 5? No, it's not. So it's going to keep going. So it's going to display it again, and it's going to add 1 to the counter, so it's 6. Now 6 is greater than 5, so it stops. But look how many times it displayed it. 1, 2, 3, 4, 5, 6. But we want to find out which code displays it 5 times. So unfortunately, A displays it 1 too many times. All right, for B, just say simply repeat 5 times, display CS principles. So does it, and it repeats it 5 times, and we're good. B is one of the answers because it displays computer science principles, CS principles 5 times. All right, let's take a look at C. It says counter is given the value of 1, so counter equals 1. It says repeat until counter equals 5. So display CS principles, okay? And then counter is given counter plus 1, so now counter equals 2. Because 2 doesn't equal 5, it keeps running. So it displays it, and then it adds 1 to the counter. And then 3 doesn't equal 5, so it displays it, and then it adds 1 to the counter. And then it displays it, and then it adds 1 to the counter. So as you see now, the counter is 5, and when the counter is 5, it doesn't repeat anything else, it stops. But if you count them, it's only displayed it 4 times, and we need 5. So C is not the answer. So just by showing these checks, this is getting us to the correct answer. And we could work through this problem, the next one, but because it says select 2 answers, we just know it has to be D. But feel free to go through this just in the interest of time. We've cancelled, we've eliminated, and we know it must be B and D. So that was number 11. Okay, question 12. The following procedure takes 2 lists, list A and list B, and adds the values of the elements together and saves them in a 3rd list. So, okay, just going through this quickly, we've got a procedure. The procedure is followed by these elements here, and then we have the command that's happening inside. Now notice what it does. It takes 2 lists A and B and adds the values and saves them in a 3rd list, C. So simply this says if a user wants to double the values in single list and save them to a double list, what is the appropriate way to call the procedure? So as you see here, what they did is they took list A and they took list B and they made list C. And this is all within the command section right here, but the parameters list A, list B, and list C are all here. So in what they're telling us to take single list and to double it and put it into double list, doubling is just really adding it to itself. So we need this parameter twice. So it almost looks tempting to go with D, but then this isn't necessarily multiplying by 2. But if you look at A, we've got the single list as a parameter, single list again, and then double list. This is very similar to this example. And here these parameters can just be added, the first 2, to get you the double list. So A is the correct answer for number 12. All right. All right, number 13. Okay. So in number 13, we're told the following incomplete code simulates a game. The roll N procedure returns the sum of the number cubes, which are numbered from 1 to 6. So the total is given the value of roll 2, which is the sum of rolling 2 dice. And so then it says if the total is less than 8, do this stuff. And then it says if the total mod 4, so if the total is a multiple of 4, then do this stuff. Okay, now we're asked, what would the value of the total be if the first time that roll 2 is executed in the above segment, the values on the number cubes were 5 and 6. So if roll 2 gave us values of 5 and 6, and we know that roll 2 means the sum, then that means that this would give us 11. The total would equal 11. So as we go through this, if 11 is less than 8, well, it's not. 11 is not less than 8, so it's not going to do this stuff. So now we move on to the next thing. 11 mod 4, if that equals 0. Well, 11 divided by 4 goes in twice, and then there's a remainder of 3. So this gives a remainder of 3, and 3 does not equal 0, so it's not going to do this. And then it stops. So the question says, what would the value of the total be if blah, 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 blah. So it wants to know the value of the total. And we have this here. The value of the total is 11. So that was question 13. Okay, so question number 14 says, consider the procedures concatenate word 1, word 2, which returns a string combining word 1 and word 2, and also another procedure called substring word 1, n1, n2, which returns all the characters from word 1 beginning at the n first character of the word up to and including the n second character. So look at this. It says, for example, it gives a little example, but let's see. So line 1. If the first word is this and the second word is this, then third word, they are saying concatenate first word, sorry, they're saying concatenate second word, first word. So that means that third word would equal the second word and then the first word pushed together. So science, computer. But these are all together. There's no gaps between these two words. And then it says display a substring of this third word 5, 10. So let's switch over the color. The 5 is going to be the fifth. 1, 2, 3, 4, 5. So this is the fifth. And then 6, 7, 8, 9, 10. This is the 10th. And so just like we see hut comes from shuttle to 4 because the second and the fourth, and then they're just pulling out those letters in between. What we do here when we do the substring of this is we go from n all the way to the m, and that's what's going to be returned. NCECOM. So for 14, C is the answer. Okay, question 15. It says consider the procedure mystery num. Procedure mystery num. The value is given 0 and then a bunch of things. So I'm going to just skip through that because effectively we're told what is returned by a call to mystery 11. So if this becomes 11, then we go straight through this. The value is 0, so val equals 0. The num is 11, so if 11 is greater than 10, which it is, that means that the value is given 0 plus the num times 2. So that means that the value becomes 0 plus 22, which is 22. Else do this stuff. But we don't need to do this because the first part of the statement was true. But now it comes on to this and it says if num is less than 12, well, our num was 11 and 11 is less than 12. So now it takes the value, which is 22, and it gives it 22 times 2. So the value now becomes 44. And then after this, this is really relating to here. After this, the value, which is right here, we're talking about this line right here, the value, which is 44, is given the value of 44 times 2, which is 88, and then it returns the value 88. So that is our answer. 15 is D. Okay, 16. Here it is. So for question 16, similar to before, but it says what is returned by a call to mystery 8. So 8 goes here, 8 goes here. So if 8 is greater than 10, well, it's not. So it's not going to do this. So what it does instead is it does this piece here, and value is 0, and that's given 0 plus the number. 0 plus num. So now at this point, val equals 8. Next, the num also equals 8, and if 8 is less than 12, which it is, it's going to do this stuff. So the value, which is 8, receives 8 times 2. So now the value equals 16. Then it does this piece here. So 16 is now given the value of 16 times 2, which is 32. And then it returns the value 32. So that's going to be our answer for number 16. Okay. This is number 17. So 17 says, which of the following code segments will display these numbers? 1, 4, 9, and 16. So let's take a look. So if num equals 1, we're told that something needs to repeat itself 4 times. So it's going to repeat 4 times. So the first time that this happens, num goes in 1 and 1. Square is 1 times 1, which is 1. And then it's going to display that number 1. And then the num becomes num plus 1. So num is now 2. So on the second time around, we've got the square is num times num, which is 4, and then it displays the 4, and then num becomes num plus 1, so num becomes 5. So now the third time that it's repeating this, the square is num times num, which is 25. And already, I don't really need to do anything else because the 1 is there, the 4 is there, but this should be a 9 and it's not. So something went wrong, so 1 is not working out for us. So we can already cancel A and we can cancel C. So it's either B or D. So I'm going to change the pen color. Let's take a look at the second segment. So the first time, num is 1 and then adder is given 3. Okay, so repeat 4 times. The first time it wants to display num, so it's going to display the 1. And then it says that num is given the value of num plus adder. Well, num is still 1 plus adder, which was 3, so num becomes 4. And adder becomes the adder, which was 3 plus 2, which is now 5. So now the second time that this thing runs, it's going to display num, which is 4, which basically is from here. It's going to display 4, and then num becomes num plus adder, which is the 4 plus the 5. 4 plus 5, which is 9. And adder becomes whatever the adder was, which was 5 plus 2, which is 7. So now the third time that this runs, it's going to display num, which is 9, which we have from here. Display 9. And then the num becomes num plus adder, which is 9 plus, let me just check this, the num is the 9 plus the adder, which is 7, so that equals 16. And the adder equals the 7 plus 2, which is 9. So now the fourth time, this is the last time for the repeat, it's going to display the num. So the num we already have all the way over here. So it's going to display 16. And then it's going to do a bunch of other things, but we already see it. Like inside each of these boxes, 1, 4, 9, and 16, those are exactly what we have here. And so code number 2, segment 2, does in fact show what we were asked. So our answer is B, 2 only. Okay, for number 18, it says consider the procedure mystery num1, num2, and assume that num1 and 2 are positive numbers. Okay, so ultimately our question is right here. It says, what does mystery num1, num2 return? So we have many things, and we could go line by line, but basically we're repeating until this is true, until the counter itself is greater than num1. And we are looking at if this num1 mod counter equals 0. So this is when num1 is a multiple of counter. And when that's true, it does this other if, which is when num2 is a multiple of counter. And when both of those two things are true, the I gets increased by 1. And then the counter at the end of this also gets incremented, but ultimately it returns I, which is only going to increase when both of these two things are true. When both num1 is a multiple of counter, and also when num2 is a multiple of counter, and that's when it does this. So keep in mind what mod does. Mod divides the two numbers and finds the remainder. And if there is no remainder, then we know that these two numbers are multiples. So even if we did 8 mod 4, that would give us an answer of 2. If we did 8 mod 4 would give us an answer of 0, because 8 divided by 4 equals 2, but the remainder is 0. When the remainder is 0, that means this mod equals 0, which means that they're multiples. And the same here. 4 divided by 4 equals 1. The remainder is 0, so 4 mod 4 equals 0. And so we know that 4 is a multiple of 4. So basically, because of what we said over here in this big bubble, num1 is a multiple of counter and num2 is a multiple of counter. When both of these two things are true, we get our I number. It returns I, which is incrementing those. It's a sum of them. And so our answer is, what does this return? It returns I, which is, let's see which one fits best. The number of digits by which both num1 and num2 are divisible. That would be our answer. So that was question number 18. Alright, so in 19, we're asked, what does mystery 9 return? So in the first case, when this is a 9, we know that the procedure runs and the sum, so let's write that up here. The sum has the value of 0 originally, and n has the value of 9. So when 9 goes in, we realize that we're going to repeat all of this stuff until n equals 0. So when this 9 is here, 9 mod 3 does not give us a remainder that is not 0. So the remainder is 0. So this statement 0 is not equal to 0. That is not true, so it's not going to run the change in the sum. But it is going to get to this point right here where it deducts 1 from that n. So when it deducts 1, this becomes 8. So then it now goes back to the top. So this bit here is part of the, up until here is part of the repeat. So now we fly back up to the top of this. Now the 8 isn't 0, so now we're going to run this. 8 mod 3, that isn't 0, so it now is going to change the sum. So the sum becomes 0 plus the n, which is 8. So now the sum is 8, and then it deducts 1 from the n, so that goes down to 7. Then we come back up to the top of the repeat. 7 isn't 0, so we get inside. 7 mod 3 does not equal 0 because 7 is not a multiple of 3. So now it does this thing with the sum. The sum, which was 8, now becomes 8 plus the n, 8 plus 7, so that's 15. And at the bottom of this, we deduct 1 from the n, so it's now 6. When 6 comes back in, so it repeats, 6 isn't 0. 6 mod 3 is 0. 0 does not equal 0. Well, that's not correct, so it's not going to do the calculation with the sum. It's just going to deduct 1 from the n. So 6 minus 1 gives you 5. This comes back up to the top. 5 is not the same as 0, so we're going to keep repeating this. 5 mod 3 is not 0, so it's going to recalculate the sum. So the sum, which was 15, plus the n, which is 5, gives us 20. Deduct 1 from the n, so that becomes 4. When we go back up, 4 equals 0. Well, that's not correct, so we're going to go inside the until, the repeat until. 4 mod 3, well, that's really 1. So 1 does not equal 0 is true. So therefore, we're going to go into the sum, and the sum becomes the previous sum plus the n, which is 24. 3 comes here because we deduct 1 from the n. 3 does not equal 0, so we go inside. 3 mod 3 is 0. 0 does not equal 0 is false, so therefore we're going to skip this bit again. And so there's no change in the sum. The m deducts by 1, so that becomes 2. We come back up the top of the repeat. 2 equals 0 is false, so we're going to keep repeating. 2 mod 3 equals 2 mod 3 does not equal 0. Well, that's true, so now we're going to change the sum. So we take the 24 and we add it to the 2. So that gives us 26. We deduct 1 from the n, so that gives us 1. 1 comes in the top. 1 mod 3 does not equal 0. Well, that's correct. So now we're going to change the sum. Sum becomes sum plus n. So that's 26 plus that 1 is 27. And we deduct 1 from the n, so that gives us 0. Now keep in mind right here, n equals 0. So when we try to repeat this, 0 does equal 0, so we stop. And then we stop with the repeat. And then at the very bottom it says return the sum. Well, the sum is 27, so that's what will be returned. So it took us some time, but we went through this in a pretty organized way using like this T-chart over here. So this kind of helped us go through and just, yeah, make sure that we get the right answer. So that was question number 19. Okay, 20. Here we're given a procedure, and this procedure deals with a list, and mylist is its name, and mylist contains the letters of the word binary. And it says, what does mystery mylist display? So when we look at this procedure mystery list, if we put the letters binary inside, so all of these letters, if we put them inside that list, for each item in the list, if item equals A, E, I, O, or U, so basically if the letter is a vowel, we're going to display that item. So when the B goes inside this code, it checks if the item is any of these things, which is not, so it doesn't get displayed. When I goes, it is, so it gets displayed. When N goes, it doesn't. When A goes, it is displayed. The R isn't, and the Y isn't, so it displays the I and the A. So C is our answer for number 20. Okay, here's 21. Okay, so for question number 21, it says a group of students with no coding experience decide to develop an anti-bullying mobile application. Which of the following will make their work easier? Select 2 answers. So often with these questions, there could be multiple answers and it's sometimes a little vague. So let's just read through them. If these students with limited limited experience, if they are set out to make this mobile application, they can A, make use of other code accessible through APIs. Well, APIs do connect to other systems and other bits of code, and so this could make things easier. Okay, B, block editors require little understanding of control structures. Well, blocks editors could help, but you still require some understanding of the control structures. So I'm not so sure about this one. C, working together, each individual's tasks are smaller. So if you work together, each of your tasks, they could be, maybe, you could save some time, maybe it would be easier. I don't know, but then you are taking on some of the other person's work as well. And then D, programmers can save time by working alone, as all properly written code that has been adequately tested will work when combined with other working code. Well, it does depend if you've coded your section to receive other code or not as well. So that's really important. So unsure about this. So my vote would be for A and C to be the answers because they seem like they fit a little better than the others. So for 21, A and C. Okay, here's 22. So consider this code segment and determine the value of count if the numbers are 1, 5, 6, 3, 3, 1. So repeat length numlist time. So numlist is 1, 2, 3, 4, 5, 6. This is going to repeat it 6 times. Length numlist is 6. So the count is 0 and the index is 0. And then let's see what this does. It says if numlist index, so if numlist index means if the item in that place is greater than numlist 1, then we're going to add to this count. Now, here's something really interesting. Numlist 1 is the first item, which is 1. So we could basically just put this here. So if numlist index is greater than 1, add 1 to the count. And then add 1 to the index so you move along. So this code is basically saying to count the numbers in this list that are greater than 1. And it will check each of the items against it. So it checks 1 against 1. Is it greater? No. Is 5 greater? Yes. 5 is greater than 1. Is 6 greater than 1? Yes. Is 3 greater than 1? Yep. Is 3 greater than 1? Yep. Is 1 greater than 1? No. So by the end of all of this, the count has increased to 4 because there are 4 numbers that are greater than 1. So that was question number 22. Okay, here's 23. Okay, so in 23, we have a bunch of numbers as well, and we need to check against this list. So the count is given the value of 0, the index is 2, repeat length of numlist minus 1 time. So 1, 2, 3, 4, 5, 6. So length of numlist is 6, minus 1 is 5. So we could think of this as just repeat 5 times. So also here it says if numlist index, so at first the index is 2. So if the second item here is greater than the one before it, then add 1 to the count. So one logical way to kind of look at this and to deal with this is to think, okay, we've got a count and we also have an index. So at the very, very beginning, we know that the count, because we're told it up at the top, is 0 and the index is 2. Now after the first time that this thing is run through, that count when we check it, because if nonelist, if this item, which is 5, is greater than the item before it, which is true, then we're going to add 1 to the count. So this becomes 1, and then the index also increases. And if you look at this, we already said we're going to repeat this 5 times. So 2, 3, 4, 5. We could set up a little table here. And one thing that we notice is that regardless of this if statement, the index always increments by 1. So 4, 5, 6, 7. And so what this is doing is it's always looking if the item is bigger than the item before it. So with the first run, we compared item 2 against item 1. Now we're going to compare item 3 against item 2. So the 6 is greater than the 5. So therefore we add 1 to the count. The 3 is not greater than the 6, so we do not add 1. The 3 is not greater than the 3, so we do not add 1. The 1 is not greater than the 5, so we do not add 1. So it says determine the value of count if the values in nonelist are these. So the value of count would be 2 by the end of this whole thing. So 2 would be the answer for 23. Okay, 24 is here. So let's take a look. In 24, we're told to consider all of this stuff, and it's meant to iterate, to go one by one through a list of test questions in random order and displaying them and then removing them. So it says, what should we replace missing code? What should we replace this with? Okay, so let's see. Procedure quiz me. It repeats until the length of the quiz is 0. It uses a random number between 1 and the length of the quiz to make an index. And so it finds a random number which corresponds to a random, the number itself must be between 1 and the length of that list. So remember what we need it to do. We need it to display and then remove the questions. So for A, it says display quiz of the index. Okay, so if it chooses number 3, it's going to display quiz question number 3, and then it's going to remove quiz question number 3. So that's precisely what we want it to do. We can't have it remove and then display. So this can't work. And if it can't do this, it can't be this. And it can't be neither if A looks good. So A is our answer for 24. Okay, number 25 is here. This is the second to last. It says, which of the following is true collaboration? Choose 2 answers. So collaboration keeps participants focused and sharing a similar mindset. So at first, this kind of looks good, except sharing a similar mindset. You know, if it's a work ethic mindset, then it's good to share that. But in terms of coding, collaboration is often better when you have different points of view, when you can come up with a solution that takes that into account. So this is not as good as when I first read it. B is collaboration requires a different skill set than coding alone. What it does, coding alone, you can be very introverted, and collaboration requires more teamwork and more, completely different set of skills as well. So yeah, you don't have to completely be extroverted, but you need to be able to be a little social with solving these problems. So I would say that B is looking good. C, collaboration requires all parts to be completed together. Nope, collaboration, you could do different parts at separate times, so I'm not really feeling this answer. And D, collaboration eases the debugging process, so makes it easier to solve problems when you have multiple people collaborating on them. So that sounds good. So my answers, I'm feeling B and I'm feeling D as the best answers. Even though A looked like it was good at the start, B and D are the correct answers. Okay, this is our last question. This is question 26. It says, from a procedure using a simple programming language, which of the following lines of code contains an error, assuming all values have been defined previously? Well, something that I'm noticing straight away with A is this parentheses here, and you know, we've only got one here and one here, so either we need to close this up or we need to remove this right here. And so this is a problem that we have this extra parentheses that's stranded, so A is going to create some error. So 26 is A.